Today we're going to be looking at the 2015 February Silver question, cow hopscotch. So in this question, we have a 2D grid, and in this grid, we have a cow that is going to be jumping around. In every value, in every spot, we're going to have a different number. So there are a couple of rules when we're jumping from spot to spot. We need to have it at least one row below, at least one column to the right, and it has to be a different number. We want to output the number of different ways we can jump from the top left corner to the bottom right corner. So the algorithm we're going to be using for this question is dynamic programming. So I guess the easiest way to get this is, in the beginning you could think that every time you move a step it would be like recursion, so you could recurse all the way down to the last step. And then obviously when you can do recursion, you can do dynamic programming. So what's going to happen is we're going to have a square, so for example we're going to be on this square, and then we're just going to look at all of the eligible squares. So we're going to just look at all of the ones that are a row down and a column to the right. We're going to check if it's a different number, and if it's a different number, we're going to add the current value of dp, let's say ij, to this value. If this value is valid, then it's also going to get added dpij, and then so on and so forth for every value. And then at the end, we'll just find the dp value of the bottom right corner. So it's a pretty simple algorithm. So there are two main parts of the pseudocode. The first part is going to be looping through the actual first point. So that's going to be this black box here. So we're going to loop through every point, and for every point, we're going to have a box like this of eligible values. So we're going to have the first black point, and then we're going to have the rest of the rows and columns. And then we're just going to check if it's eligible, which just means if it has a different number. And then if it is, we're going to do what I said earlier and do dpxy, and we're going to add the value of dpij to that. And that's the basics of the program. Okay, so now let's move on to the code. The first thing we're going to do is we're just going to read in the input, and this is pretty standard. And then we're just going to get started on the DP. So the code for this program is relatively simple. As usual, I'm going to type def long as LL. So we're going to create the dynamic programming array, and then we are going to set the value of 0, 0 to 1. And this is just going to initialize it so that all of the other values are able to actually add something. So the next thing we're going to do is we are going to loop through all of the locations to get the starting location. So it's just going to be from 0 to R and then 0 to C, or row and column. And then we're going to look at all of the possible locations that ij could go to. So this is going to be X and Y. And this is just going to be one row down and then one column to the right, just like the problem specifies. And then the third constraint, all we have to do is we're just going to check whether or not the values are the same. If the values are not the same, that means we can't add them, so I'm just going to add the value here, and then because the question does ask for mod, I'm going to mod this value. And then at the end here, we're just going to output the dp last value mod.